Welcome back, everybody. Today we're in section 2.1 talking about linear functions. Before we can talk about linear functions, we need to have a little bit of a discussion about slope. All right. Now, while many of you may have heard of slope before, and people often call the slope the rise over the run. All right, I want to start talking about slope in terms of average rate of change, okay? All right, because when you head to calculus, right, you're going to start talking about average rate of change, and I want you to already relate it to the slope. It's a very important topic for calculus. So there is a formula for slope, and slope is denoted with m. All right, and it is y2 minus y1 over x2 minus x1. All right, so if you know me, you know that very often I've always had trouble remembering formulas. And so there was a problem that I always had. The problem I always had was which of these formulas is correct for slope? Well, I decided to test it out to see if the order really mattered or if it was just consistency mattered. All right, so I'm going to have you guys test it out as well. All right. So we're going to do the example, and we're going to say that we're going to find the slope of the line containing the points -1, 4 and 2, -3. We're going to say find the slope. All right, so it really is a plug and chug type of thing. So I'm going to ask you to pause the video. And I want you to plug in your numbers, and I want you to see for yourself, do you get the same answer with both versions of the formula, or do you get a different answer with both versions of the formula? And we will talk about it on the back end. All right, so hopefully you plugged in. If I call this point 1 and this one point 2, then I can say it would be the first way would be -3 minus 4 over 2 minus -1 plus positive, which would be -7/3. And then I would get 4 minus -3 over -1 minus 2, and that would be 7 over -3, which either way would be the same number. So what you see is that it's not necessarily the order of the formula that matters. It's being consistent with which one's point 1, which one's point 2, and plugging in the right x and y value there. All right, so one of the really good things is that knowing the slope can help you graph the line. You wouldn't necessarily need to always make a table of values. So if I asked you, let's say, to draw a line that contains the point (3, 2) and has a slope of 3/4. All right. We can then just go right to the graph and say 1, 2, 3, 1, 2, and put that there. And then if we have a slope of 3/4, I'm going to rise 3, and I'll do this in green. It's imaginary. I'm rising 3. and I'm running to the right 4. And then, because my straight lines are never so straight on this, use my ruler. And there's your line. So you see, having a really good understanding of slope is really, really helpful. Now that's good for a positive slope, but let's say we were drawing a line that contains the point 3, 2, but now I want to change the slope. I don't want a slope of 3/4 anymore. I want a slope of -4/5. All right. Now, there's always confusion with where the negative goes. It's fairly conventional to put the negative with the top number. And I think it makes a lot of sense, because if it's rise over run and I'm rising -4, right? Wouldn't that be logical to be falling 4? 1, 2. So 1, 2, 3, 4. And then still run to the right 5. 1, 2, 3, 4, 5. Put a point here. And remember, we started at the same spot. And there's our line. So when you have a negative slope, like I said, relate the negative to the top number. To me, it makes sense to rise -4 means to fall 4. So that's the way you would make your line. Again, you could always make a table of values, but in this case, we really couldn't. We don't have a function just yet. All right. But the good part is that we could always make a function. All right. There's many different ways to get the form of a line. One way is point slope form. All right. And point slope form is y minus y1 equals m times x minus x1. I personally like point slope form. It really does come from the slope formula. If you look at the slope formula, if I multiply both sides times my denominator here, I wind up with that formula right there. All right. So, and depending on the information given in your problem, point slope form might actually be a more efficient way to go. So let's take a look at an example. Find the equation of a line with a slope of -3 containing the point -1, 4. So point slope form is ideal when you're given a point and you're given a slope. And in this problem, we're given a point and a slope. Not saying this is the only way you have to do it, but this is a very efficient way. So x1, y1 is going to be -1, 4, and my slope equals -3. So I wind up substituting into my point slope form. I get y minus 4 equals -3 times x minus -1. Now I'm separating those out to show you that I'm putting x minus -1. But you can simplify it right away to be like that. Now, I usually like to put my final answer in slope-intercept form, meaning solve it for y equals. So I'm going to distribute and say y minus 4 equals -3x minus 3, and then add 4 to both sides and get y equals -3x plus 1. And that's the way most folks are going to like to see it. All right, so Let's try another one. Very similar concept. All I'm going to do is just change up the information. Find the equation of the line that passes through the points -2, 1 and 3, 7. Put your final answer in slope-intercept form. So I've given you a point. I've actually given you 2 points. Doesn't matter how many points I give you. As long as they're on the line, you can always use it in point-slope form. What's the difference in this problem from the last one? In this problem, I didn't give you the slope, but I did give you 2 points. So we can do our slope formula. And we can say, let's say, 7 minus 1 over 3 minus -2, which would wind up being 6 over 5. We don't care if we have a whole number slope or not. That doesn't bother us, right? Now, as far as point slope form goes, I need to pick a point. Which one should I pick? You should pick whichever one seems easier for you to calculate with. Some of you will look at this problem and say -2, 1 is going to be the easier point because they're smaller numbers. Some of you are going to say 3, 7 because they're both positive. Makes me feel good. I like positive numbers. So whichever one you pick is up to you. I'm going to pick 3, 7. So I'm going to say y minus 7 equals 6/5 times x minus 3. Right? And now I'm just going to whittle it down and get y equals. So I'm going to distribute. And I have y minus 7 equals 6/5 x minus 18/5. And then I'm going to add 7 to both sides. And when I do that, 7 is what in fifths? Let's say 35 over 5. 6/5 x plus, and this would be 17/5. All right, so we've tried one where we've given a slope and a point. We've tried one where we're given 2 points. And I could give you a wide variety of these problems and just change up the information that's given. I could give you 1 point. I can give you 2 points. I could say slope of a horizontal line. It would just be a matter of recognizing the information I gave you. Okay, let's step it up a notch. All right, here's a question I've used on a quiz before. Find the slope, the y-intercept, and the x-intercept of the line 3x minus 4y plus 12 equals 0. Now here I've given you no points. And we're combining some concepts from multiple sections, x-intercept, y-intercept, as well as slope. All right, so the first thing I want to do is I want to put it in a form that maybe I can recognize some of that stuff. So first thing I'm going to think of is y equals mx plus b, which is slope-intercept form, right? We all slope-intercept form. And we know that m is slope and b is the y-intercept. All right, if I could take this equation up here and put it in this form, I could get 2 of the 3 of my things right away without having too much work to do. So let's give it a try. Basically, what I would need to do is take this equation, 3x minus 4y plus 12 equals 0, and solve it for y. So I'm going to add 4y to both sides. Okay, and I get 4y equals 3x plus 12. Now I'm going to divide by 4, and y equals 3/4 x plus 3. So the information I've gained from this is my slope equals 3/4. My y-intercept equals 3. And now to find my x-intercept, what do? I let y equal 0. So find the x-intercept. Set y equal to 0. Now you could do it in the original equation, or you could do it in this equation. I like using the original equation. In this case, in most cases, it probably make things easier. So I have 3x minus 4y equals -12, right? So I've did a little work with this equation as well, right? I moved the 12 to the other side in an effort to try to solve it. All right, so we're left with 3x equals -12 and x equals -4, and there is my x-intercept. All right, and again, not a particularly difficult question. It's mainly a quiz question because we're combining a couple of concepts together and asking you to do it in a single problem. All right, so the last thing I want to talk about is getting back to what I said in the beginning, is that average rate of change idea. All right, so if we have the average rate of change, right, and I want the average rate of change from A to B, right? Right? A and B would be our x values. Now I need to run them through our function in order to get the y values, right? So we have f of A and f of B. So there's our points. And now if we put them into the slope formula, I get f of B minus f of A all over B minus A. And there is my average rate of change, or slope. So let's do this with a practical example. I'm going to say my function is 3x squared, and I want to find the average rate of change from 1 to 7. All right, so we start out, our first step is I need 2 points. So I have 1 comma something and 7 comma something. I don't know what those somethings are yet, but I can figure them out by taking my 1 and my 7 and plugging them into my function. So why don't you pause the video right now, take 1, plug it in, take 7, plug it in, and we'll talk about the y values on the back end. All right, so I plugged in 1 and I plugged in 7. I got 1, 3, and 7, 147. All right, and now to get the average rate of change, I just need to use the slope formula. So I get 147 minus 3 over 7 minus 1. So that gives me 144 over 6. And the key here is you need to simplify this as much as you can. All right, so 6 goes into both of them. So 6 into 144 is 24 over 1. Therefore, your final answer is 24. And that is the average rate of change from 1 to 7 if my function is 3x squared. All right, so that's it for part 1. Part 2 will have a few other applications. Thanks for listening, guys, and I look forward to seeing you again soon.